continuing talking about multi-digit whole number operations. Today we're going to be talking about decimals and uh, how to use the area model with decimals and how that makes sense and why it works. So first, in order to understand how we can use the area model with decimals, we need to know what decompose mean. When I think of what decompose means, I think of zombies and how they break down, right? When we think of decomposition, it's the point at which something breaks down, and the same thing goes with numbers. What does that mean? Well, in this case, we can take a very simple, let's use some fun colors, a simple number like 7.24 and know that this means 7 and 24 hundredths. So to break it down, we can say that this is 7 ones and that this is 24 hundredths. So we can break the number down, right? So that is one way to break down or rename a number. Now there's another way that we can do it if we pick a different number. We can say that this is 2 ones and 23 hundredths, or 2 and 23 hundredths, or we can just pull out the decimal and rename it to something just a little easier to work with. And I'm going to show you why it's easier to work with. So this would be 223 hundredths. It would be equal to the same thing, right? And the same thing goes with, for instance, if we had one more, like 3.2, this could be 3 ones and 2 tenths, or we can just call it, this 32 tenths. Okay, so that's how we would decompose a number or break down a number. That's decomposition, right? So now that we understand what decompose means, what does that mean for decimal operations? Well, I'm going to tell you. In this case, we could take a number and we're going to multiply 22 times 2.4. Now, with all numbers, one of the things that we want to do when we multiply two numbers, especially decimals, is estimate what it might look like. Well, we round the numbers. 22 would round to 20, and 2.4 would, we'll just say 2. So our estimation, our answer is going to be somewhere around 40, or we think. And now let's look at what that looks like if we use the area model. So the area model, if I pull this apart, what I can do is, I know my answer is going to be around 40, right? It's going to be around 40, so should get something around 40. Now, when I do this, and if I do this correctly, I'm taking my original answer here, and I'm going to use that for the area model. Well, I have my one side, 22, which is 20 plus 2. But now for my other side, I'm going to rename it. Instead of 2.4 and putting that in my area model, what I'm going to do actually is I'm going to fix it, right? And I'm going to call this 24 tenths, right? Which means that it's 20 plus 4 tenths. So I've renamed it. And what this does is it makes it a little easier for me to set up. So now I can just add these over, and this is what we were talking about in class, but 20 times 20 is 4 with 2 zeros, 400. 20 times 4 is 80. 20 times 2 is 40. And 2 times 4 is 8. Now if I add these all together, 400 plus 80 is 480, plus 40 more is 520, plus 8 is 528. 528. Here's where we need to make sure that we do this correctly. Tenths. So we need to make sure that this translates. This is all in tenths because we multiplied by tenths. I'm going to show you the standard algorithm. What is 528 tenths? Well, that's easy. That's 52.8. Because it's 528 tenths, that translates to 52.8. Again, let's try that problem one more time. If I get rid of that, I get rid of that, we have this problem. How do we use the standard algorithm? It translates the exact same way. So we had 24 tenths multiplied by 22. 2 times 4 is 8, 2 times 2 is 4, 2 times 4 is 8, 2 times 2 is 4. What does that equal? Hopefully 528. Carry the 1, it equals 528. And again, we see the standard algorithm. Let's bring that down. Tenths, don't forget the tenths. What is that in terms of numbers with decimals? Well, it's 52.8. So this answer would equate to that. And that's how we connect those and use decomposing or renaming numbers to connect that to multiplying decimals and whole numbers.